this problem. The question is again using the delta to Y conversion, we have to find the Thevenin equivalent resistance. Each resistance R is given as 1 ohm. So that we have to find the resistance between these 2 points. Let me mark as A and B. Each resistance is given as 10 ohm. So all the resistance value is 10 ohm. Now you have to use delta to Y conversion. So this problem I will do in both way, Y to delta and delta to Y. So first let me do in delta to Y conversion manner. So now look at this. When I'm looking, this is appearing to be a delta network. See, this resistor, this resistor, this resistor. It's connected in a delta manner. So if I converting it to Y network, these two resistors, between this point, one resistor. Between these two resistors, nothing is there. So from here, another resistor of Y. Between these two, next resistors of Y network. So this is the way just I converted this Y network, delta network to Y network. So let me mark this as R1, this as R2, this as R3. Alright, so now I have to find R1, R2, R3. Before that, I will redraw this diagram. So this part, no changes here. Only these three resistors will go off. It will replace by the Y network on this. So let me see how your circuit now will look like. So initial part, there is no change. So you have A. From A, you have 10 ohm resistor. This 10 ohm. This 10 ohm. This 10 ohm. This 10 ohm. No change for this many part. Now you have been added here. This is not there. This is not there. This is instead of that R1, R2, R3. Instead of that R1, R2, R3. So from this point, if I look at this point between these two resistors, so this point I have connected R2, or to this 10 ohm resistor I am connecting R2. So this is R2. Fine. Now to this resistor we have R1. To this resistor we have R1. And the other end of R1 is connected to R2. The other end of R1. So this point you have R1 and other end of R1 is connected to R2. This point you have R2, other end of R2 and R1 are connected together. Now from this point I have R3. This point I have R3. The other end of R3 is again connected to R2. So now the circuit to become like this. So now this and this side. So this is already we know this is 10 ohm. 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 Now we need to find what is R1, R2 and R3. Okay. So what's R1? R1 is, look at this. It's between these two resistors. So 10 into 10. Divided by the total resistance 10, 10, 10. So 10 plus 10 plus 10. So it is 100 divided by 30. 100 divided by 30. So you will be getting around 3.33 ohm. Now what's R2? Everything are same. All are 10, 10 resistors. So R2 means this 10 and this 10. So 10 into 10. All the three resistors are 10. So it is again 30 ohm. So it is come up with the same answer 3.33 ohm. Now R3. R3 is what? This resistor. It is between this 10 and this 10. So it's again 10 into 10 divided by 10 plus 10 plus 10. So again end up with the same answer 3.33 ohm. So now this is 3.33 ohm. This is again 3.33 ohm. This is again 3.33 ohm. Now look at this. These two resistors are connected in series. These two resistors are again connected in series. These two resistors are again connected in series. So 10 and 3.33 connected in series means it is 13.33. This is again 13.33. This is again 13.33. So now circuit these 6 resistors, now you can reduce to 3 resistors plus these 2 resistors. And this is your point B. Between these two you have to find the resistance value. So now your circuit become so between A and B you have two 10 ohm resistors, 10 ohm, 10 ohm. No change for that point, A and B. Now here you have 13.33, here you have 13.33, here also you have 13.33 resistor. So here you have 13.33 ohm, here again 13.33 ohm, here again 13.33 ohm. So now your circuit is reduced like this. So again, now again this point is common, so three branches, 3 resistors are meeting here. You cannot consider these resistors either series or parallel. So again we have to go for another delta to Y conversion. So any part, see it's become like a previous network. So and again you need to use either this here a delta to Y or here a delta to Y. So any one point you need to have again a delta to Y conversion. So one more time you have to perform delta to Y conversion. So when I do that, see these two resistors I have the point 1 Y resistor point. Between these two I have the second then, and between these two I have the third Y. Say marking as say R1, say R2, say R3. Okay, suppose R1. So R1 is equal to between these two, right? So 10 multiplied by 13.33. Now when I write this R1, these two resistors, these 3 resistors are replacing this. So now 13.3. Now the total resistor is 10, 13.33 plus 13.33. So divided by 10 plus 13.33 plus 13.33. So our answer is 3.63. So now R2. So R2 is again between this and this. So it is 10 and 13 point, same way. 10 into 13.33 divided by 10 plus 13.33 plus 13.33. So the same answer 3.63. So now we have R3. R3 is between this and this. So it is 13.33 multiplied by 13.33 divided by this. So 13.33 plus 13.33, and we are getting the answer as 4.85. And all these are ohm, resistance, all are. So now if you replace this diagram, see now this part is replaced by this network. So how this R1, R2, between A and B you have R1, R2, and this point you have R3. This is your point A. Okay, so and now from there you have 10 ohm, and then you have 13.33 ohm. So that's it. Now your circuit is reduced to. So now your circuit is reduced like this. So now you have to again find between A and B is the point R equivalent. Still it is not in a directly resolving condition. So now if I am putting the values of R1 and R2, this is 3.63, R2 is again 3.63, R3 is 4.85. Now you look this R3 and 13.33. These are connected in series. So these two R3 and this resistor are connected in series. So now if you are taking the series combination of these two, this is connected in series. So that means that is 4.85 plus 13.33. So the answer is, it is 18.18 ohm. Now if you look R2 and this 10 ohm, that both are again connected in series. See, these two also are connected in series. So you have 3.63 plus 10. So that means 13.63. But now these two are connected in parallel. 13.63 and 18.18 are connected in parallel, and that will come in series with this. You will get the equivalent resistance. So now your circuit is now changed to, you have here your 3.63 ohm. Now in this point you have connected two resistance. One is 13.63 ohm, should come parallel with 18.18 ohm. And this is your point A. This is your point A. Here you have to find the R equivalent. These two are connected in parallel. So when you take the parallel combination of this, so total R equivalent, if I am taking total R equivalent, is equal to 13.63 parallel with 18.18 plus this is 3.63 plus 3.63. So when you do that, it is 13.63 multiplied by 18.18 divided by 13.63 plus 18.18 plus 3.63. We'll be getting it as 11.43 ohm. So that is the R equivalent of this resistance, and by using delta, we have only considered delta to Y conversion. So only by using delta to Y conversion we have done it, and R equivalent we are getting it as 11.43. You can verify the same using your multisim. Just connect the circuit in the multisim by arranging the resistance in the same manner what is given in the original question. And you need to calculate the resistance between this point and this point. So take a multimeter and connect it over here. Put your multimeter in ohm. You should measure the resistance ohm. So make the resistance measurement mode. After that, just run it so that these two are AB. This 2 point you have to find. So when you run it, 11.429. So 11.43. So you can verify your answers in this manner by using multisim simulation, whether your mode method is correct or not.